Building Blocks of Geometry, Lesson 1.1 from Discovering Geometry. Nature's great book is written in mathematical symbols, Galileo Galilei. 3 building blocks of geometry are points, lines, and planes. A point is the most basic building block of geometry. It has no size. It has only location. You can represent a point with a dot, and you can name it with a capital letter. The point shown below is called P. A tiny seed is a physical model of a point. A line is a straight, continuous arrangement of infinitely many points. It has infinite length, but no thickness. It extends forever in 2 directions. You name a line by giving the letter names of any 2 points on the line and placing the line symbol above the letters. For example, line AB or line BA. A piece of spaghetti is a physical model of a line. A line, however, is longer, straighter, and thinner than any piece of spaghetti ever made. Mathematical model of a line. A plane has length and width but no thickness. It is like a flat surface that extends infinitely along its length and width. You represent a plane with a 4-sided figure, like a tilted piece of paper drawn in perspective. Of course, this actually illustrates only part of a plane. You name a plane with a script capital letter, such as P. Mathematical model of a plane. A flat piece of rolled out dough is a model of a plane, but a plane is broader, wider, and thinner than any piece of dough you could roll. We will skip the investigation. It is difficult to explain what points, lines, and planes are, yet you probably recognize several models of each in the investigation. Early mathematicians tried to define these terms. The ancient Greeks said, "A point is that which has no part. A line is breadthless length." The Mohist philosophers of ancient China said, "The line is divided into parts, and that part which has no remaining part is a point." Those definitions don't help much, do they? A definition is a statement that clarifies or explains the meaning of a word or phrase. However, it is impossible to define point, line, and plane without using words or phrases that themselves need definition. So these terms remain undefined, yet they are the basis for all of geometry. Using the undefined points, point, line, and plane, you can define all other geometry terms and geometric figures. Many are defined in this book, and others will be defined by you and your classmates. Here are the first definitions. Begin your list and draw sketches for all definitions. Collinear means on the same line. A, B, and C are collinear. Coplanar means on the same plane. E, D, and F are points that are coplanar. A line segment consists of 2 points, called endpoints of the segment, and all the points between them that are collinear with the 2 points. You can write line segment AB using the segment symbol, like this, or like this. There are 2 ways you can write the length of a segment. You can write AB equals 2 inches when there is no symbol above AB, and this means the distance from A to B is 2 inches. You can also use M, this italicized M, for measure in front of the segment name and write the distance as measure of segment AB equals 2 inches. If no measurement units are used for the length of the segment, it is understood that the choice of units is not important or is based on the length of the smallest square in the grid. Figure A, figure B. Figure A, the distance between AB equals 2 inches, or the measure of segment AB is 2 inches. Figure B, measure of segment MN is 5 units. 2 segments are congruent segments if and only if they have the same measure or length. The symbol for congruence is this symbol. You say it as is congruent to. You use the equal symbol between numbers and the congruent symbol between congruent figures. When drawing figures, you show congruent segments by making identical markings. For instance, these single marks means that two segments are congruent to each other. These double marks mean SP is congruent to RQ, and the triple marks mean SR is congruent to PQ. The midpoint of a segment is the point on the segment that is the same distance from both endpoints. The midpoint bisects the segment or divides the segment into two congruent segments. Example, letter A, name each midpoint and the segment it bisects. I know it looks like F is halfway between E and G, but I have no proof of that. So I can't say that F is a midpoint of EG, but I can say that F is a midpoint of CG. I know that, or CD, I know that to be a fact because the measure is stated 2 centimeters on either side of F. In the second figure, HJ and HL are marked congruent to each other. However, H is not collinear with J and L, so H is not a midpoint. K is a midpoint of the segment JL, and I know that to be true because it is marked with double ticks. Even though N looks like it's halfway between M and P, I have no proof of that. So I cannot say that those two are, that N is a midpoint. Letter B says name all the congruent segments and use the congruent segments to write your answer. Here is the solution to part A and part B. Ray AB is the part of line AB that contains point A, and all the points on line AB that are on the same side of point A is point B. So imagine, if I'm looking at ray AB, imagine cutting off everything to the left of A. What remains is ray AB. In the figure above, ray AB and ray AY are two ways to name the same ray. Note that ray AB is not the same as ray BA. Ray AB begins at this endpoint and travels in the direction towards B. Ray BA would start at point B and travel the same direction as A, all of those points. Those two, the red and the blue rays, are not the same. A ray begins at a point and extends infinitely one direction. You need 2 letters to name a ray. The first letter is the endpoint of the ray, and the second letter is any other point the ray passes through. So ray AB starts at point A and continues on through B infinitely in that direction. This is a physical model of a ray. These are beams of light. They have a definite starting point, the source of the light, and they continue infinitely on in the other direction.